Welcome to my YouTube channel. Dhanesh here. So today I am going to discuss about the theory on electrostatics. See, in electrostatics we have, we uploaded many videos. All those videos are related to IIT JEE questions, both mains and advanced, and their solutions. So now I am going to cover the theory related to electrostatics. In this video, let me start with the origin of electrostatics. So the word electrostatics, it goes back to 600 BC. In 600 BC in Greece, it goes back to 600 BC in Greece in Thales of Miletus, one place known as Thales of Miletus. See, in this place, the people, they understood, like, when amber, it's a type of resin. It amber means it's a type of resin we are obtaining from trees. So this amber means it is it is a type of resin, and when this amber is rubbed with some other substance, glass, or some other substance, or silk, it has the capacity to attract lighter objects. So the Greek word for amber is electron. So the Greek word for amber is electron. So the people in this place, Thales of Miletus, in 600 BC, they understood, like, when amber is rubbed with some other substances like silk or glass, it has the capacity to attract lighter objects. The Greek word for amber is this. The Greek word for amber, this is like this, you can write it. So the Greek word for amber is electron. From this word electron, the word electrostatics is originated. This is the way the word electrostatics is originated. See, electrostatics means electro means, I told you, it is related to electrons, and statics means rest. So from these two words only the word electrostatics is originated. So electrostatics means it's the study of electric charges at rest. Electrostatics means it's the study of electric charges at rest. And you need to understand that when substances are rubbed together, one substance will get positive charge and the other substance is getting negative charge. For example, when glass is rubbed with silk, glass and silk, when you take glass and silk, glass will get positive charge and silk will get negative charge. The reason is the electrons are transferred from glass to silk. The electrons, the negative charged particles, atom contains positively charged nucleus, and the electrons are revolving around the nucleus. These electrons are transferred from glass to silk. See, if the substance which loses electrons will get positive charge, and the substance which gains electrons will get negative charge. So you need to understand, when glass is rubbed with the silk, electrons are transferred from glass to silk, and the glass will get positive charge and silk will get negative charge. So this is this is what happening during rubbing. And one more thing here you need to understand here is the electrons are transferred. See, when electrons are transferred, the substance that loses the electrons will get positive charge, and the substance that gains the electron will get negative charge. Charge is of two types. One is positive charge, and another one is negative charge. There are two types of charges. One is positive charge and another one is negative charge. That's what I am telling you. So charges are of two types. One is charge when you take charge, see here, charge when you take, it's of two types. One is positive charge and another is negative charge. So now I am going to talk about charge. So what is charge? The definition for charge is the most fundamental quantity. Charge is the fundamental quantity in electricity. If somebody asks what is charge, what you will tell? Charge is the fundamental quantity in electricity. You know about fundamental quantities and derived quantities. In physics, you have fundamental quantities and derived quantities. In mechanics, mass, length, time are the fundamental quantities. See, charge is the fundamental quantity in electricity. What is the unit of charge? You know it. The unit of charge, it is Coulomb. So another thing you need to understand, unit it is Coulomb. Unit of charge, it is Coulomb. I am telling you, unit of charge, it is Coulomb. This also you can understand. So what is the definition? See, when you learn a physical quantity, you need to understand all these aspects: its definition, its formula, its unit, its dimension, then whether it is vector or scalar. So what is the definition for charge? Charge is the fundamental quantity in electricity. Its unit is Coulomb, and it's since it is a fundamental quantity, it's not having a formula. If somebody is asking what is the formula for mass, no, we can't tell. It's a fundamental quantity. What is the formula for length? No, it's a fundamental quantity. There is no such formula. In the same way, charge is also not having a formula. So its unit is Coulomb. We measure it in microcoulomb, nanocoulomb, like that. And one more thing is it's a scalar quantity. It's very important. First point. Second point, it is a scalar. Physical quantities are classified into two: vectors and scalars. Vectors are physical quantities having both magnitude and direction. Scalars are physical quantities having only magnitude but no direction. So you know that vectors and scalars. And another thing you need to understand is the dimension, the dimensional formula for charge. The dimensional formula for charge, see, from this formula only you come up with the dimensional formula for charge. I is equal to Q by T. From here you can write Q is equal to IT. What is the dimension for current? It is ampere. A denotes the dimension. From this formula only we are writing the dimension. Q is equal to IT. And what is the dimension for T? Capital T. So these 3 points are really important. So the first point, it is the unit of charge, it's Coulomb. The second point, charge is a scalar quantity and its dimension is AT. So this is another aspect you can keep in mind for charge. Now I am getting into the next concepts. See, next thing what I am going to discuss here is I am going to discuss here is what are all the characteristics of charge. That's what I am going to tell you. So we are going to discuss about the characteristics of charge. You can listen here. One is characteristics. First characteristics is, it is the fundamental quantity in electricity. Fundamental quantity in electricity, charge, first characteristics. Second characteristics, you can remember it as charge is of two types. One is positive charge, another one is negative charge. That is the second characteristics. The third characteristics is like charges, like charges, it will repel. Like charges repel and unlike charges will attract. That is the next characteristics. It's a symbol. Positive and positive will repel, positive and negative will attract. That is the third characteristics. And the fourth characteristics, it is charge is conserved. Conservation. conservation. This you know, charge is conserved. Conservation means you are familiar with law of conservation of energy, law of conservation of matter, law of conservation of momentum. You might have learned it in the 11th grade. So conservation means it can neither be created nor be destroyed. So charge is conserved. That means charge can neither be created nor be destroyed. So charge is that's the law of conservation of charge. So that is the fourth characteristics. Then I am going to come to the fifth characteristics. It's really important. So that some formula also we need to learn related to that. So I will discuss in detail about that fifth characteristics. So you understood the four characteristics. The first characteristic is it's the fundamental quantity in electricity. Second one, charge is of two types, positive and negative. Then like charges repel, unlike charges attract. Conservation of charge, charge can neither be created nor be destroyed. And fifth characteristics, it is condensation of charge. So that that is the fifth characteristics we are going to discuss. Fifth characteristics is condensation of charge. Quantisation. So condensation of charge means the charge acquired by a substance is an integral multiple of the basic unit of charge. That means when a substance is getting charged, it is always an integral multiple, or integral multiple means it will be 2 times, 3 times, 4 times, 5 times, like that. So charge acquired by a substance is an integral multiple of the basic unit of charge. The basic unit of charge is charge of an electron. What is charge of an electron? You know it. 1.602 into 10 raised to minus 19 Coulomb. This is charge of an electron. See, charge of a proton is also same. Charge of an electron means it should be minus. Charge of a proton means this much plus. That's why atom is electrically neutral. See, the charge, I told during rubbing, substances are getting charged, right? Electrons are transferred from one point to another. So when they get charged, what's happening? So the charge acquired by that substance excuse me. So the charge acquired by that substance is an integral multiple of this charge. That means a charge acquired by this substance will be Q is equal to, charge is denoted by the letter Q, is equal to plus or minus Ne. This is the most important, the first equation. This is really important equation. You will get MCQs based on this equation. See, the charge acquired by a substance Q is equal to plus or minus Ne. So this is the this is the equation for condensation of charge. So you understood the concept. The concept is the charge of an electron is 1.602 into 10 raised 602 into 10 raised to minus 19 Coulomb. That means the charge acquired by a substance should be integral multiple N into E. N should be, you can get it like this. N should be, here N should be, N is equal to 1, 2, 3, etc. So this is the case that N should be an integral multiple. That means the charge acquired will be 1 times the charge of the electron, or 2 times the charge of the electron, or 3 times the charge of the electron. So this is the condensation of charge. E is equal to 1.602 into 10 raised to minus 19 Coulomb, and Q is equal to plus or minus Ne. So this is known as condensation of charge. And charge, all 5 characteristics I explained. Conservation of charge I explained. So this is about charge. So what's the unit of charge? Coulomb. So charge is a vector or scalar. Charge is a scalar quantity. So these are all the important aspects you need to remember about charge. Now I will discuss with you about the next important aspect in this chapter, that is Coulombs law. Let us discuss about Coulombs law. So Coulombs law next is a very important law. it is Coulomb is a scientist. He only introduced this law. So what is Coulombs law? See, you understood, like when positive and positive bring together, they will repel each other. Positive and negative attract. So there is a force. So actually, what type of force? It's a non-contact force. You may be familiar with this. See, forces are classified into two. One is the contact force and non-contact force. Contact force means all mechanical forces are contact forces. But when you talk about gravitational force, electrostatic force, magnetic force, even there is no contact, a force is existing between charges, magnets, and even stars, galaxies. So in that case, we introduce the concept of field, electric field, magnetic field, gravitational field, and such forces we call it as non-contact force. Even though there is no contact, a force is existing. Such forces we call it as non-contact force. Non-contact force. So electrostatic force is a non-contact force. Contact force means mechanical forces like friction, viscosity, or all mechanical forces. See, these forces are contact forces. See, for example, if you want to take your calculator, you need to touch it. Without that you can't take it. So that's a mechanical force. It's a contact force. So now we are coming to the Coulombs law. See here, the force between charges, it's like we can tell it as it's a non-contact force, and I am going to discuss about Coulombs law in detail. Our portion is Coulombs law. So what is Coulombs law means? Here see, you have two charges. One is the plus Q charge. Here you have two charges. One is the plus Q charge. Here you have the minus Q charge. Just 1 second. Here, yeah. So here you have the plus Q charge, and this is a minus Q. The separation between these two charges is R. Then there must be a force of attraction, right? If both are plus, there is a repulsion. So according to Coulomb, the force of attraction, this charge we are taking it as Q1, and this charge we are taking it as Q2. The separation is R. According to Coulomb, the force of attraction or repulsion between 2 point charges is directly proportional to the product of the charges Q1 into Q2, and inversely proportional to the square of the distance between the charges, and inversely proportional to the square of the distance between the charges. This is what Coulomb is telling. The 2 points. What is Coulomb's law? The statement you can remember like this. Coulomb's law states that the force of attraction or repulsion between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So F proportional to Q1, Q2, F inversely proportional to R square. So these two mathematical inequalities you can combine, right? See, I told you, this is what I told you. F proportional to Q1, Q2, then F inversely proportional to R square. When you combine these two, Q1, Q2 divided by R square. So how do you change the proportionality? You will introduce a constant. So here the constant, it is really important, 1 by 4 pi epsilon 0 into Q1, Q2 divided by R square. So what is epsilon 0? Epsilon 0 is known as the permittivity of free space. Very important. Permittivity of free space. Permittivity of free space or vacuum. See, permittivity of free space. See, what is permittivity? Permittivity is the ability, permittivity of a medium is the ability to transmit electric lines of force. So electric field is visualized by using electric lines of force. We will discuss it later. Electric lines of force we will discuss. See, for the time being, you need to understand epsilon 0 is known as the permittivity of free space. So what is epsilon 0? Permittivity. What is permittivity? It is the ability of a medium to transmit, to conduct electric lines of force. The ability of a medium to conduct magnetic lines of force is known as permeability. That we will discuss it. That we will discuss it in another chapter, that is electrodynamics, moving charges and magnetism, that is permeability. So this is permittivity. Epsilon 0 is known as the permittivity of free space, and its value, it's really important, so we will discuss that as well. It is epsilon 0, I will tell you, epsilon 0 is equal to, you need to by heart this, 8.85 into 10 raised to minus 12. From that formula you can write the unit, Coulomb square, Newton raised to minus 1, meter raised to minus 2. This is the unit, you will get it. See, how do you get the unit? It is like see, I told it is 1 by 4 pi epsilon 0 q1 q2 divided by r square. From this, how you can write epsilon 0 is 1 by 4 pi f q1 q2 divided by r square. Then you can write the units for this. What is the unit of a constant? No unit. So from this, when you are writing the unit, 1 by f, q1 q2 will be Coulomb square, Coulomb into Coulomb, 4 pi no unit, Newton divided by Newton, r square, meter square. That's what I have written, Coulomb square, Newton raised to minus 1, meter raised to minus 2. This is 1 by Newton. By the law of exponents, it's Newton raised to minus 1, meter raised to minus 2. That is epsilon 0 is 8.85 into 10 raised to minus 12 Coulomb square, Newton raised to minus 1, meter raised to minus 2. This is the value of epsilon 0. So what is Coulomb's law? Coulomb's law states that the force of attraction or repulsion between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. See, one more thing you need to understand. See, if we can substitute this value of epsilon 0 here, it is 8.85 into 10 raised to minus 12. See, I have this is the formula, right? 1 by 4 pi epsilon 0 q1 q2 divided by r square. When you substitute epsilon 0, you will get 8.85 into 10 raised to minus 12. Here you can substitute, then it will become 9. This is very important for numerical, q1 q2 by r square. Your formula is simplified, so you can get it like this. This is your formula. Is it correct? 9 into 10 raised to 9. Just I substituted epsilon 0 here. This epsilon 0, the value of epsilon 0 I substituted here. This is epsilon 0. This epsilon 0 I substituted in this equation, and when you calculate this, you will get this 9 into 10 raised to 9 into q1 q2 by r square. So this is another equation for Coulomb's law. Now see, whatever equations I am discussing here, if the medium is free space, see, that's what epsilon 0 is the permittivity. Permittivity is the ability to transmit electric lines of force. So this equation, whatever we are discussing, is for free space. If there is a medium, see, the equation will be modified. So that one will be, if there is a medium, then the equation will be modified. I will tell you the equation. So then the equation should be excuse me then the equation is, I can tell you the equation, f is equal to 1 by 4 pi epsilon 0 epsilon r q1 q2 divided by r square, and epsilon r is known as the epsilon 0 is the absolute permittivity, epsilon r is known as the relative permittivity of that medium. relative permittivity. So this is another equation. So 1 by 4 pi epsilon 0 epsilon r q1 q2 by r square. This is the relative permittivity of that medium. So this is all about Coulombs law. So Coulombs law states that the force of attraction or repulsion between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. The same equation you can write it in vector form. So I will show you that as well. It is like so you need to put the vector sign here. So sorry, just 1 second. We have to see, just 1 second. We need to put the vector sign here. See, this is vector f is equal to q1 q2. Charge you cannot convert it into a scale vector. Charge is a scalar, so into r cap. So r cap it's needed. It is r cap. I will write it correctly. 1 second. R cap. So r cap is a unit vector. Cap, it denotes the unit vector, and vector f is equal to 1 by 4 pi epsilon 0. I will write it correctly. 1 second. Just I will write it neatly. So this is the vector equation. You will get it. See, vector f is equal to 1 by 4 pi epsilon 0 q1 q2 divided by r square into r cap. R cap is a unit vector. See, vector f, this is the vectorial representation of Coulombs law. So we covered the origin of electrostatics, how it is originated. Now what are all the characteristics of charge, what is charge, then Coulombs law it's covered. So that's all in this video. Thanks for watching.